July 1944. Normandy hedgerows. American tank crews are dying in their Sherman tanks at alarming rates. The problem isn't German infantry or artillery, it's German tanks. When a Sherman encounters a Panther or Tiger, the result is predictable and horrifying. The Sherman's 75mm gun can't penetrate German heavy armor from any practical combat range. The German 75mm or 88mm gun punches through Sherman armor like paper, igniting ammunition and killing crews instantly. Shermans must use tactics, flanking, numbers, ambushes, to survive encounters with German armor. Even then, losses are catastrophic. Tankers have dark jokes. A Sherman can kill a Tiger from the side at 500 yards. A Tiger can kill a Sherman from any angle at 2,000 yards. You do the math. Frontline mechanics and tank crews watch their friends die. They see Shermans brew up, catch fire after being hit, again and again. They read after-action reports showing 5-to-1, sometimes 10-to-1 loss ratios against German heavy tanks. And they get angry. The mechanics, men whose job is to repair damaged tanks and keep units operational, start asking, why can't we fix this? We can weld. We have steel. We have tools. Destroyed German tanks litter the battlefield. Why not take their best parts and make our Shermans better? The answer from command is clear: unauthorized modifications to military equipment are illegal. Tampering with tanks voids warranties and violates regulations. Don't do it. The mechanics do it anyway. This is the story of how frontline mechanics, tankers, and maintenance crews illegally modified Sherman tanks into some of the most powerful American armor of World War II, and how the Army tried to stop them before eventually embracing their innovations. To understand why mechanics felt compelled to modify Shermans, understand what the Sherman was designed for, and what it faced instead. The M4 Sherman was designed in 1940-41 based on expected threats: German Panzer III and IV tanks with 50 to 75mm guns and moderate armor. The Sherman was supposed to be reliable, easy to maintain, mechanically sound. Mobile, fast for exploitation and pursuit. Producible, simple enough for mass production. The Sherman excelled at these design goals. It was mechanically excellent, adequately armed and armored for 1942-43 threats. Against Panzer IIIs and IVs, Shermans performed well. But by mid-1944, the Sherman faced threats it wasn't designed for: Panther tanks with sloped 80mm frontal armor and high-velocity 75mm guns. Tiger tanks with 100mm frontal armor and 88mm guns that could destroy Shermans at 2,000 plus yards. Even upgraded Panzer IVs with improved armor and guns. The Sherman's 75mm M3 gun, excellent against 1942 threats, was inadequate against 1944 German armor. At combat ranges, 500 to 1,000 yards, it couldn't penetrate Panthers or Tigers frontally. The Sherman's armor, 50 to 75mm, was vulnerable to German guns from any angle at any range. American tank doctrine emphasized numbers and mobility over individual tank superiority. The theory: overwhelm German armor with multiple Shermans, accepting losses. This worked strategically. America could replace losses faster than Germany. But it didn't help the crews dying in burning Shermans. Frontline soldiers don't care about strategic exchange ratios. They care about surviving the next engagement. And Shermans, as issued, didn't give them good odds against German heavy armor. The men who would illegally modify Shermans weren't engineers or designers. They were frontline mechanics, enlisted men and NCOs responsible for maintaining tanks in combat zones. These mechanics came from diverse backgrounds: pre-war auto mechanics who knew engines and metalwork. Farm boys who'd been fixing tractors since childhood. Factory workers with welding and machining experience. Some had technical training from army schools. Most learned on the job. Their official role was maintenance and repair, fix mechanical breakdowns. Replace damaged components. Perform field maintenance to keep tanks operational. Return tanks to original specifications per Army regulations. But these men saw the results of design inadequacy daily, friends killed in tanks that couldn't fight back. Shermans destroyed by hits they couldn't survive. Crews demoralized by equipment that left them outgunned and underarmored. And they had resources, welding equipment for field repairs. Steel from destroyed vehicles, Allied and German. Tools and workshops in rear area maintenance depots. Access to damaged tanks for parts scavenging. Technical knowledge from military training and pre-war experience. Most importantly, desperation born from watching men die in inadequate equipment. The mechanics made a collective decision, regulations be damned, we're fixing this problem ourselves. They began experimenting with modifications in July-August 1944, working after official hours, using scrap materials, operating in a legal gray area between unauthorized modifications and field expedient repairs. What started as individual initiatives would become an underground movement transforming Sherman capabilities, until the Army noticed and tried to shut it down. The simplest and earliest modification, adding extra armor. The concept was straightforward, weld steel plates onto Shermans to increase protection. Mechanics scavenged steel from destroyed tanks, knocked out German vehicles, structural steel from damaged buildings, and even ship plate when available. Early applique armor efforts were crude, flat plates welded to hull front and turret. No engineering analysis, just more metal equals more protection. Welding quality varied from excellent to dangerous. Weight distribution ignored, some tanks became nose-heavy or sluggish. But it worked. Shermans with extra frontal armor survived hits that would have penetrated standard armor. Crews loved it. More importantly, word spread. Tankers began requesting applique armor from maintenance units. Mechanics began systematizing the process, developing standard patterns, improving welding techniques, calculating weight distribution. The Army's response was immediate and negative: unauthorized modifications void maintenance contracts. Additional weight stresses drivetrain, increasing mechanical failures. Improper welding can crack hull integrity. Modifications make tanks non-standard, complicating logistics and replacement. Orders came down: stop adding unauthorized armor. Remove existing modifications. Return tanks to standard configuration. The mechanics ignored these orders. They'd seen the armor work. They weren't going to condemn crews to death for regulatory compliance. So they got sneaky. Modifications were done at night or in forward positions where inspectors rarely visited. Paperwork was creatively interpreted: field repair of combat damage rather than modification. Friendly officers looked the other way. The underground armor program continued and expanded. By September 1944, hundreds of Shermans in Europe had some form of applique armor, all technically illegal, all installed by mechanics determined to keep their tankers alive. Mechanics quickly discovered that steel wasn't the only armor material. When steel plate was scarce, they improvised: concrete-filled spaces, welding steel boxes to hull and filling them with concrete created composite armor. The concrete absorbed shell energy even if steel penetrated. Sandbags, cheap, available, surprisingly effective against some hits. Crews stacked sandbags on hull and turret. Effectiveness was debatable, but psychological value was real. Wood and concrete combinations, layered wood and concrete between steel plates created spaced armor that disrupted shaped charges. Track links, extra track sections welded to hull provided additional protection and were easily sourced from damaged tanks. These modifications varied wildly in effectiveness: some helped against high explosive rounds but not armor-piercing. Some were pure placebo, making crews feel safer without actually helping. Some genuinely improved survivability against certain threats. The Army metallurgists and engineers who eventually studied these field modifications were appalled at the lack of scientific rigor but impressed by the innovation. One report noted, "These modifications show no understanding of armor physics or metallurgy. They also show remarkable ingenuity and desperation." Some solutions are surprisingly effective despite being theoretically unsound. The concrete-filled boxes, initially mocked by engineers, actually worked against some German rounds. The concrete's brittleness helped shatter or deflect projectiles. It wasn't as good as proper armor steel, but it was better than nothing. More importantly, it was available. Mechanics could mix concrete from local materials. The modification program was becoming sophisticated despite its illegal status. Mechanics shared techniques through informal networks. Successful modifications were copied across units. A body of practical knowledge developed outside official channels. Adding armor helped survivability, but Shermans still couldn't kill Panthers or Tigers effectively. The 75mm M3 gun was the limiting factor. Mechanics began exploring solutions. British 17-pounder gun. British forces had developed the Sherman Firefly, a Sherman mounting the powerful 17-pounder gun capable of penetrating German heavy armor. Could Americans do the same? The problem, the 17-pounder modification required extensive turret work. The gun was physically larger and needed different mounting. The modification was beyond field capabilities without specialized equipment. American 76mm gun. The U.S. had developed the 76mm M1 gun with better anti-armor performance than the 75mm. New production Shermans were being fitted with this gun. Could it be retrofitted to existing 75mm Shermans? The answer, theoretically yes, but practically difficult. The 76mm required a different turret or major modifications to existing turrets. Some maintenance depots had the capability, but field mechanics didn't. Nevertheless, some attempted it, using turrets from destroyed 76mm Shermans to replace damaged 75mm turrets on salvaged tanks. Accidentally requisitioning 76mm turrets during repairs and installing them on 75mm hulls. Convincing depot personnel to perform the conversion as battle damage repair. These gun swaps were even more illegal than armor modifications. Changing the main armament was explicitly prohibited without authorization. But desperate measures for desperate times. Mechanics and crews wanted guns that could fight German armor on equal terms. If official channels wouldn't provide them, unofficial channels would. Some mechanics went further. What about mounting even more powerful guns? The U.S. had 90mm anti-aircraft guns, and the M26 Pershing tank would eventually mount a 90mm. Could Shermans be upgunned to 90mm? Several attempts were made. One maintenance unit tried mounting a 90mm AA gun on a Sherman chassis. The recoil destroyed the mounting after 3 shots. The turret ring couldn't handle the weapon's size. Another unit attempted to use a Pershing turret on a Sherman hull. The weight distribution was catastrophic. The front suspension collapsed. One enterprising mechanic tried to modify a Sherman to accept a captured German 88mm gun. This failed spectacularly when the gun's recoil ripped the turret off the hull during test firing. These failures taught important lessons. You can't just stick bigger guns on existing platforms. The entire system, mounting, recoil, turret, hull, must accommodate the weapon. Some modifications are genuinely impossible without complete redesign. The mechanic's enthusiasm occasionally exceeded engineering reality. But even failed experiments contributed to knowledge. Mechanics learned the limits of field modification. They developed respect for the engineering challenges designers faced. And they refined their understanding of what modifications were practical versus fantastical. The consensus emerged: armor modifications equals practical and effective. Gun changes to 76mm equals possible with depot support. Anything beyond 76mm equals requires factory-level work. The modification culture was maturing from try anything to do what actually works. By fall 1944, the modification program had evolved into an underground technical network spanning multiple armies in Europe. How it worked: mechanics would document successful modifications with sketches and notes. When units rotated to rear areas or sent liaison personnel to depots, they'd share information. Successful techniques spread through word of mouth and informal documentation. Failed modifications were also shared, saving others from repeating mistakes. This unofficial knowledge base included standard applique armor patterns for different Sherman variants with weight calculations and mounting instructions. Techniques for welding armor without cracking hull integrity. Methods for acquiring materials through creative requisition. Ways to disguise modifications as legitimate repairs and paperwork. Contacts at depots who were sympathetic and would look the other way or actively help. The network operated like an underground railroad, but for tank modifications. Information flowed through personal connections. A mechanic transfers to a new unit and brings his knowledge. Tank crews discuss modifications with crews from other units during rest periods. Officers sympathetic to the program facilitate inter-unit communication. Maintenance personnel meeting at supply depots exchange information. This decentralized knowledge sharing meant innovations developed in one sector rapidly spread across the front. A successful armor configuration developed in Patton's Third Army would appear in Bradley's units within weeks. The Army was losing control of its own equipment standardization. Hundreds, perhaps thousands of Shermans were operating with non-standard configurations. Logistics officers struggled to track which tanks had which modifications. Maintenance became complicated. Modified tanks needed different parts and had different failure modes. But the program was too widespread to stop. Attempting to remove all modifications would have required pulling entire tank units offline. The momentum was unstoppable. By November 1944, senior Army leadership was aware of the widespread modification program and deeply concerned. Official orders came down: all unauthorized modifications must cease immediately. Existing modifications will be removed and tanks returned to standard configuration. Personnel found modifying equipment will face courts-martial. Maintenance chiefs are responsible for ensuring compliance. The reasoning was legitimate from Army perspective. Standardization is critical for logistics and training. Modified tanks might have unknown weaknesses or failure modes. Legal liability if modified equipment fails and kills crews. Maintaining proper military discipline and chain of command. Inspectors were sent to frontline units to enforce compliance. What they found shocked them: entire tank battalions with non-standard armor configurations. Maintenance shops openly welding modifications. Officers who knew about modifications but tolerated or encouraged them. A culture of non-compliance so widespread that enforcement seemed impossible. The inspectors tried. They ordered modifications removed. They threatened mechanics with punishment. They wrote reports documenting the scope of unauthorized modifications. And they largely failed. Why enforcement failed: removing modifications required time and labor. Units couldn't spare operational tanks for compliance work. Mechanics removed modifications when inspected, then reinstalled them after inspectors left. Tank crews actively resisted, sometimes threatening violence if their armor was removed. Officers at battalion and company level supported their men over distant headquarters. The modifications worked. It was hard to justify removing armor that saved lives. Most importantly, the war was still being fought. Nobody wanted to explain why combat capability was reduced for regulatory compliance. The crackdown created tension but didn't stop the program. Realizing they couldn't stop the modifications, Army leadership shifted strategy: if we can't beat them, join them. In late 1944, the Army began authorizing field expedient modification programs, supervised applique armor installation at depot level with engineering oversight. Official patterns and weight limits for armor additions. Quality control for welding and materials. Documentation of modifications for logistics tracking. This compromise served multiple purposes: gave legitimacy to what was happening anyway. Brought modifications under some degree of control and standardization. Improved modification quality through engineering input. Reduced the most dangerous amateur modifications. Maintained regulatory framework while accommodating battlefield reality. The mechanics were vindicated. Their illegal modifications became semi-official programs. Techniques developed in underground networks were formalized and improved. But the compromise had limits, only certain modifications were authorized. Many of the more aggressive changes remained prohibited. Depot capacity couldn't handle demand, long waits for official modifications. Some units continued underground programs for faster turnaround. A two-tier system emerged, official modifications done at depots following approved patterns. Unofficial modifications done at frontline maintenance units using proven underground techniques. The Army tacitly accepted this system. Official policy said one thing. Battlefield reality was another. Officers learned to balance regulatory compliance with combat effectiveness. The mechanics had won, partially. Their innovations were recognized and incorporated. But the tension between standardization and customization would continue throughout the war. Some maintenance units took the modification concept to its extreme, creating super Shermans that combined multiple improvements, maximum applique armor, heavy frontal armor using the best proven patterns. Additional side and turret armor where weight distribution allowed. Track link armor on vulnerable areas. Upgraded armament, 76mm gun when available, officially or otherwise. Improved ammunition stowage for better penetration rounds. Better sights and optics when they could be sourced. Mechanical improvements, upgraded suspensions to handle additional weight. More powerful engines or engine modifications for better performance. Improved transmission cooling to handle stress. Enhanced survivability features, better fire suppression systems. Improved escape hatches. More ammunition stowage protection to prevent brew-ups. These super Shermans represented the peak of field modification culture. They were significantly more capable than standard Shermans, approaching or matching German tank capabilities in armor and firepower. Mechanically stressed, the additions pushed systems beyond design limits. Maintenance nightmares, each was unique, requiring custom parts and repair approaches. Expensive in time and resources to create. Not all modifications worked together well. Some combinations created new problems. Too much armor made tanks slow and unmaneuverable. Engine upgrades stressed transmissions. Weight distribution issues affected accuracy. But the most successful super Shermans were formidable. Reports describe modified Shermans surviving multiple hits that would have destroyed standard models. Modified Shermans with 76mm guns and heavy armor going head-to-head with Panthers and winning. German accounts mentioning encountering heavy American tanks that didn't match known Sherman specifications. These were the illegally built tanks referenced in the title, not factory products or official programs, but field creations by desperate mechanics determined to give their crews fighting chances. The critical question: were modified Shermans actually more effective in combat? Evidence from multiple sources suggests yes. After-action reports show lower loss rates for units with heavily modified tanks compared to units with standard Shermans. Tank crews overwhelmingly preferred modified Shermans and fought to keep them. German accounts occasionally mention encountering unexpectedly well-armored American tanks. Surviving modified Shermans show evidence of hits that penetrated outer armor but were stopped by base armor, suggesting the modifications absorbed energy. Statistical analysis from ordnance departments, conducted post-war, shows modest but real improvements in survivability. However, the benefits weren't universal. Some modifications helped in specific scenarios but not others. Armor effective against high explosive wasn't necessarily effective against armor-piercing rounds. Weight penalties reduced mobility, sometimes negating armor benefits. Mechanical reliability suffered in some heavily modified tanks. The most effective modifications were well-designed applique armor on frontal arc, measurably improved survivability. 76mm gun upgrades, significantly improved anti-armor capability. Ammunition stowage improvements, reduced catastrophic kills from ammunition fires. The least effective were random armor additions without engineering thought, added weight without protection. Overambitious gun modifications, usually failed mechanically. Modifications that severely impaired mobility, made tanks easier targets. Overall assessment, the modification program improved Sherman combat effectiveness measurably but not dramatically. Modified Shermans were better than standard Shermans but still inferior to German heavy tanks in direct combat. The real value was psychological. Crews felt less helpless and fought more aggressively. Knowing your tank had every possible advantage improved morale and combat performance in ways statistics couldn't measure. By early 1945, the Army had fully reversed its position on modifications. Not only were field modifications tolerated, they were studied, systematized, and incorporated into official doctrine. Ordnance departments interviewed mechanics, documented successful modifications, and created official modification kits based on field innovations. Engineering teams analyzed why certain illegal modifications worked and incorporated those principles into new designs. The most successful field modifications were incorporated into factory production. New Shermans came with features that started as illegal field modifications, improved armor configurations based on field applique patterns. Better ammunition stowage derived from field improvements. Enhanced survivability features that mechanics had improvised. The Army also began formal programs acknowledging modification needs, authorized modification packages for existing tanks. Training for maintenance personnel on approved modifications. Supply chains for modification materials. The mechanics who'd been threatened with courts-martial months earlier were now being consulted as technical experts. Their illegal innovations had become official doctrine. This represented a rare example of bottom-up innovation in military organizations. Enlisted mechanics identified problems that designers and officers missed or couldn't address quickly. They developed solutions using available resources and practical knowledge. The informal network spread innovations faster than official channels could. Eventually, official channels recognized the value and incorporated the innovations. The process wasn't clean or easy, but it worked. The Sherman of late 1944-45 was significantly different from the 1943 model, not just because of factory improvements, but because field modifications forced the Army to evolve its approach. The ultimate vindication of field modification culture was the M4A3E2 Jumbo, an officially produced assault Sherman incorporating many concepts from illegal field modifications. The Jumbo featured massive armor, up to 150 mm on the front, thicker than a Tiger. The applique armor concept taken to its engineering limit. 75 mm gun initially, though some were upgunned to 76 mm, purpose-built for assault operations where armor mattered more than mobility. Critically, many Jumbo design features directly derived from field modifications, the applique armor concept, proven by mechanics adding steel plates. The focus on frontal armor, learned from analyzing which field modifications were most effective. The willingness to sacrifice some mobility for protection, a trade-off mechanics had been making all along. Only 254 Jumbos were produced, but they proved the field mechanics had been right. Shermans could be made much more survivable with more armor, even if it cost mobility. Crews loved Jumbos for the same reasons they loved field-modified Shermans: they could take hits and survive. The Jumbo validated everything the illegal modification program had argued for. But it arrived late, not deployed until September 1944, long after mechanics had started adding armor themselves. The Jumbo represents what could have been, if the Army had listened to frontline feedback earlier. Properly engineered heavy Shermans could have been fielded sooner. Instead, mechanics had to innovate illegally to solve problems the Army was slow to address officially. Post-war analysis suggests the Jumbo should have been prioritized much earlier. But military bureaucracies move slowly, and mechanics couldn't wait for official solutions. The mechanics who illegally modified Shermans weren't heroically defying orders without consequences. They took real risks. Courts-martial, unauthorized modification of military equipment was a serious offense. Potential prison time if prosecuted. Career destruction. Even without courts-martial, mechanics could face demotions, bad conduct discharges, or career-ending reprimands. Physical danger. Improper modifications could fail catastrophically. Poorly welded armor could crack and injure crews. Overstressed components could fail in combat. If a modification caused crew deaths, the mechanic responsible could face manslaughter charges. Professional reputation: if modifications failed, mechanics were blamed. Success was taken for granted, failure was punished. Most mechanics proceeded anyway because, the alternative, doing nothing while crews died in inadequate tanks, was morally unacceptable. They believed their technical skills and knowledge were valid even if unofficial. They had support from crews and frontline officers, even if higher command disapproved. The practical reality was that enforcement was difficult in combat zones. Several mechanics did face punishment, some were demoted for unauthorized modifications. Others were transferred away from frontline units to rear area positions. A few faced courts-martial, though most charges were eventually dropped or reduced. But most mechanics escaped official punishment because, the modifications worked, making it hard to justify punishing success. Officers protected their mechanics from higher-level scrutiny. The chaos of combat made tracking individual accountability difficult. Eventually, the Army embraced the modifications, retrospectively legitimizing what had been illegal. The mechanics' willingness to risk their careers for their beliefs about tank improvement represents genuine moral courage, putting soldier welfare above regulatory compliance and personal safety. The Sherman modification program had lasting impacts beyond World War II. It demonstrated that frontline soldiers often understand equipment needs better than distant designers and planners. It proved that informal technical networks can innovate faster than official channels. It showed that regulations should serve combat effectiveness, not vice versa. Post-war, the U.S. military incorporated lessons from this experience, formal feedback mechanisms from combat troops to designers. Authorized field modification programs with engineering oversight. Recognition that standardization must balance with customization for specific missions. Faster procurement processes to address identified equipment deficiencies. The Vietnam War saw similar dynamics, soldiers modifying M16 rifles, adding armor to helicopters, customizing equipment. But thanks to World War II experience, these modifications were handled with less resistance. Modern military culture accepts that combat troops will customize equipment. The question isn't whether to allow it, but how to channel it productively. Special operations forces explicitly authorize extensive customization. Standard units have some latitude for authorized modifications. Rapid fielding programs incorporate combat feedback quickly. The Sherman modification story is taught in military logistics and engineering courses as a case study in bottom-up innovation. The tension between standardization and effectiveness. The importance of listening to frontline feedback. The Sherman mechanics would be surprised to know their illegal activities became textbook examples of good military practice. But their legacy is clear. They proved that desperate soldiers with practical skills can sometimes solve problems that engineers and generals cannot. The title claims field-modified Shermans were the most powerful American tank of World War II. Is this accurate? Reality check: the M26 Pershing, introduced in 1945, was more powerful than any Sherman variant. Heavy tanks like the T-29, never deployed, had better armor and guns. Even fully modified Shermans were still inferior to German Tigers and Panthers in direct comparison. So why the claim? The answer is nuanced, most powerful in context. For most of a European campaign, Shermans, including modified versions, were the most powerful American tanks actually in combat in significant numbers. The Pershing arrived too late to matter. Most powerful relative to baseline, the improvement from standard Sherman to fully modified Super Sherman was dramatic, arguably the biggest capability jump for any American tank during the war. Most powerful for their weight class, modified Shermans punched above their weight class, approaching heavy tank capabilities in medium tank chassis. The real story isn't that modified Shermans were objectively the most powerful American tanks. It's that mechanics and crews, working with limited resources and facing bureaucratic opposition, created tanks significantly more capable than official production models, and did so faster than official procurement could respond. In this context, most powerful refers to the power of innovation outside official channels. The capability that desperation and ingenuity can create. The strength of soldiers refusing to accept inadequate equipment. It's a statement about human determination as much as tank specifications. The mechanics didn't create superweapons. They created incremental improvements that saved lives and demonstrated that the official system wasn't optimizing for combat effectiveness. Not everyone celebrated the modification program. Critics, both wartime and post-war, raised valid concerns. Safety issues, improperly modified tanks could be death traps. Cracked welds could fail under stress. Weight-stressed components could break catastrophically. Some modifications made tanks more dangerous to crews than leaving them stock. Logistics nightmares, every non-standard tank complicated supply chains. Maintenance was harder with unique configurations. Training was inconsistent, crews didn't know what they'd get. Parts didn't interchange as designed. Legal and liability concerns, if a modification failed and killed crews, who was responsible? The mechanic? The commanding officer? The army? Without official authorization, legal accountability was murky. Discipline and chain of command issues, allowing widespread violation of regulations undermined military discipline. If soldiers could ignore equipment regulations, what other orders were negotiable? The precedent was potentially dangerous. Resource diversion, time and materials spent on modifications could have been used for other purposes. Optimal allocation of scarce resources was questionable. Some Army engineers argued, we designed Shermans carefully to balance protection, mobility, firepower, and reliability. Field modifications upset this balance unpredictably. A few successful modifications don't prove the approach is sound. These criticisms had merit. The modification culture did create problems. But frontline response was, you designed Shermans to fight 1942 threats. We're fighting 1944 threats. Your design doesn't work for current reality. We can wait for you to catch up, or we can fix it ourselves. The debate highlighted a fundamental tension, engineers prioritizing systemic optimization versus soldiers prioritizing immediate survival. After the war, the Army conducted extensive analysis of the modification program. Official studies concluded, positive outcomes, modification program improved Sherman survivability measurably. Field innovations accelerated official design improvements. Mechanics demonstrated valuable technical capabilities. Crew morale improved with better equipped tanks. The program showed flexibility in adapting to unexpected threats. Negative outcomes, some modifications were ineffective or counterproductive. Logistics and maintenance were significantly complicated. Safety incidents occurred due to improper modifications. Resource allocation was sometimes suboptimal. Regulatory framework was undermined. Lessons for future, establish better feedback mechanisms from combat to designers. Create authorized field modification programs with engineering oversight. Balance standardization needs with customization benefits. Improve procurement speed to reduce need for field improvisation. Respect practical knowledge of frontline soldiers and mechanics. These lessons influenced post-war military development. Korean War saw authorized modification programs from the start. Vietnam-era equipment included provisions for field customization. Modern military acquisitions emphasize rapid prototyping and combat feedback. Special operations forces have extensive customization authorities. The Sherman modification story became a teaching case. What happens when official systems can't keep up with battlefield reality? How to balance standardization with adaptation. The value of empowering technical experts at all levels. The importance of listening to combat soldiers. 60 years later, military planners still reference the Sherman modifications when discussing equipment adaptation and innovation in combat. The story of illegally modified Shermans is ultimately about people, not machines. It's about mechanics who refuse to accept that their friends should die in tanks they knew could be better. Officers who looked the other way because they valued their soldiers' lives over regulations. Tank crews who fought harder knowing their tanks had every possible advantage. And an army that eventually learned to listen to its frontline troops. The modifications themselves weren't revolutionary. Adding armor isn't rocket science. Swapping guns and improving components are straightforward engineering. What was revolutionary was the culture, bottom-up innovation in a top-down military organization. Practical knowledge challenging engineering authority. Soldiers taking ownership of their equipment and survival. The willingness to break rules for what they believed was right. The most powerful American tank wasn't any specific modified Sherman. It was the combination of the Sherman's solid baseline design, the mechanics' determination to improve it, the knowledge shared through underground networks, the Army's eventual recognition and embrace of field innovation. This created a system, informal, illegal, chaotic, but effective, that adapted faster than official procurement could. That system, more than any individual tank, was the real weapon. Today, when military historians study the Sherman, they often focus on technical specifications, production numbers, and combat statistics. But the most important Sherman story isn't about machines. It's about the men who refused to settle for good enough when lives were at stake. The mechanics who worked through nights welding armor. The crews who fought in tanks they'd helped design. The officers who protected their men from bureaucracy. These men didn't wait for perfect solutions from distant engineers. They grabbed welding torches and went to work. They broke regulations, risked careers, and sometimes endangered themselves to give their fellow soldiers better chances. That determination, to act rather than accept, to fix rather than complain, to risk rather than conform, is the real legacy of the Sherman modification program. The mechanics who illegally built better tanks weren't just improving equipment. They were proving that soldiers who care enough, know enough, and dare enough can change outcomes that others accept as inevitable. That's a more powerful weapon than any tank.